Okay, this is the video solution for problem number 2 of lab section 53 of the midterm. As you can see, this is a beam problem. It must be solved with beam problems, okay? And it's a must, okay? And to get full marks, obviously. And uh, the geometry is given here. Okay, notice that these cross sections of these two pieces is different from the cross section of the circular arc. Okay, and a load is applied at the center downward of 200 magnitude 200 pound. So in order to use symmetry, we need to only model half of this. That's obvious. And when you apply the load, it's going to be half of that, which is 100. Okay, so let's go ahead and do this. There are different ways of doing it. If you follow my instructions in class and the examples that I did, but you can do it your own way. It doesn't matter. I'm going to create 4 points, actually 1, 2, 3, and a center point here, the point here. So point G, A, B, and then instead of this point C, I will create the center point here because I want to specify the circle uh, with the center and radius. Okay, and there are other ways of doing it. You do your own way. Okay, so let's go ahead and start with the part file. Uh, oops, part file. Okay, and immediately I'm going to save this. So we have a file, save management, save as, desktop. I'm going to make a new folder. Let me see, I already have, okay, so I'll make a new folder here. And I'll call it Lab 53. Problem 2. Which incidentally is a beam problem. Okay? So everything is going to go there. And we're going to create 4 points in space. And those 4 points are G, A, B, and the center point that I mentioned. So let's put units here. This is G, 0, minus 10, and 20. 0, minus 10, and 20. Okay. Another one, which is the coordinates of the point A, is going to be 10, minus 10, 20. Another one that's going to be, let me zoom out. Another one that's going to be coordinates of the point B, which is 30, minus 10, 0. 30, minus 10, and 0. Okay, that's this point. And I would like to create a coordinate right there, a point right there, which is the center of that circle, and that happens to be, let me see, 30, 0, 0. 30, 0, 0. And when you're done, you just cancel to close this window. So I should have my points here. All right, so let's do the line from this point to that point. Another line from this point to this point. And then you need a circle with that center and radius of, I believe it's 10, right? I believe it's 10. So obviously you have to be in generative shape design in order to create a circle. If you're in part design, you cannot create a circle. Okay, you won't find a circle icon there, but it's right there. You click on it, and you use the method of center and radius. So the center is right there, and the radius is 10, and the support is the XY plane right there. It's just that you have to fool around with these angles so that you get the right thing. So let me see now. Let me try between, okay, if this is 0 and 180, 0 and 180, we're talking about probably minus 90 and 0. How about that? Let's try that. Minus 90 and 0. Preview. Yeah, that's good. That's good. There we are. Okay. Now remember, in class I suggested that we join all of these. Okay, join all of these because later on we're going to mesh it right at the same time. And then when we apply property, we're going to put the same property on everything here, except that later we changed the property of this to a different radius with a local 1D property. Okay, so first thing that we're going to do is join. Join is here. Join that guy and this guy and that arc or circle right there. All right, let's apply material properties to this. Everything is made out of steel. So it's metal out of steel on the entire part. And we say OK. And we are pretty much done here. So we're going to go to generative structure analysis. OK. And we're going to mesh it. Because we joined these things, it's going to do it right at the same time, all of them. 0.5, OK, that's fine. And we apply 1D property to the joint, entire joint. Now remember, these two lines have the same radii, but this one does not. So first we're going to make everything the same. And I think that is 0.75. That is correct. That was the correct radius here. Let's see, somewhere down here it says 0.75, and then this one is 0.5. Very good. So let's go there, and we say OK, and puts it there. We say OK, and then we put the cursor on properties, right-click, local 1D property, and then we select this circle down here, and click on the wrench, and we put 0.5. Okay, 0.5. What I had there before is correct. Okay, so close it. Notice that what happened is that originally we put down a radius of 0.75 here, but this is going to override it. It becomes 0.5. So these are smaller than that, obviously. All right, so let's save our analysis. File, save management. Analysis, save as. Just the right folder. 53, problem 2 beam. Yep, that's good. Okay, what do we know? The top is clamped. This top point is clamped. So we're going to clamp it. Do not put it on the point because you will take it, but later on when you run it, you won't see it. It has to be on the vertex. So hide this point and select the vertex. Right there, you can see that. Okay. Now this point, let me hide these things first of all. These properties, we're going to hide it. Okay. That point is in the XZ plane of symmetry. So it does not move in Y and rotation is opposite. So we click on the user define. Okay. That point, that vertex, not the point really, does not move in the direction Y, direction 2, and rotations are exactly the opposite. That's the symmetry condition here. Okay. And then we're going to apply a downward force of half of that. Okay. So you go to load, which is right here, and this is distributed force. Okay, see if you can zoom in here and select this point. And in the direction Z, minus 100, we say okay. There we are. Save everything. And I'm pretty sure we can run it. Okay, let's look at this. All right, so we're going to run this. Okay, let's look at the deformation or displacement. That's better. Double click on this thing. Choose average ISO. Okay, so you can animate it. And because you did the proper restraint, symmetry restraint, if you look at the view from the front, you see that this point does not go to the left or to the right, just go up and down. Okay, and that's all we wanted to do. We wanted you to do for this test. Okay, save everything. The one comment that I have is some of you may have decided not to. The different ways this could have been done. Okay, some of you may have decided not to join these lines and that curve. If you do that, then when you measure it, you have to do this separately. and you have to assign properties separately, which is fine. However, at the juncture, there are duplicate nodes, one from this side, one from that side, and they should be a connection can be created between them, and that connection should be declared as rigid. And the same thing down here, which is perfectly okay as long as you have done it that way and it's right. It's good. You're going to get your part mark. You're going to get your marks. Okay. Now, this is it.